Hey, I'm Yakov, and this is the second part of the Swift macros deep dive. If you haven't seen the first part, I recommend you do so before watching this video. In the first part, I explain the idea behind macros, show you their different kinds, and talk about some implementation quirks which really affect how you write macros. Basically, if something in this video looks strange to you, you'll most likely find an explanation in the first part. You should see a link in the corner, and I'll also leave it in the description. If you find this video helpful, please don't forget to give it a thumbs up. Also, subscribe to the Swiftbird and consider sponsoring the channel at the links below. This way you can really help me work on future episodes, because, it takes a lot of time. With that said, let's start with the demo. You've heard multiple times that macros are now part of Swift, but that is only half the truth. In its latest version, Swift has embraced the client side of the macros infrastructure. In other words, you can call macros out of the box without any preparation. But to write your own macros, you need to link the Swift syntax package. This library is published by Apple and includes the tools for parsing, generating, and updating Swift code. You won't need to import it manually, because the macro template built into Xcode 15 will do it for you. If you prefer the command line, you can also create a macros package with the Swift package command. Another thing I want to highlight is that the macros declaration and implementation live in separate modules. That's because of how macros are discovered, compiled, and called. But again, the template will handle this for you. And now let's have a look at the demo project. Here I have a small iOS app. It's a social network for birds. The app consists of just one module and one view. The bird struct, which represents the app user, has only two properties right now, but in the future I'd like to extend it with another one. The view is also pretty simple. It allows one bird to add another as a friend. This screen is not complete yet, and my goal today is to fill in the gaps with the help of Swift macros. Specifically, I have 3 missing pieces, and I'll implement them using the 3 different kinds of macros I explained in the previous video. First, here I have this check which prevents the user from adding themselves to friends. However, the view knows too much about birds' internals, and that doesn't seem right. Second, I'd like to display the other user's favorite food here. And third, the buttons don't do anything at the moment. Let's assume I can't add a real implementation just yet, but it's important that I don't forget about it later, so ideally I should have some kind of a reminder. So, these are my 3 goals for this demo. Let's start with adding a macros target. This is probably the easiest part of the task. I start by going to File, New, Package, and selecting the Swift macro template. This template creates a Swift package with a few products, targets, and dependencies. In addition to the actual macros library, I get an executable target which I can use as a playground. I don't need it for this project, so I'll probably remove it off camera. The crucial part of this package is this dependency. As I mentioned earlier, writing Swift macros requires the Swift syntax library, and here, as you can see, the template imports it automatically. Finally, let's have a look at the targets in this package. I've got the macro target which provides the implementations. I find the way Xcode automatically names it pretty confusing, so I will probably rename this later. I also have this library target which exposes the macro declarations. And finally, I've got the client and test targets. I will remove both of them for now, but I'll add the test target back when I need it later in this video. The Xcode template provides one example, this stringify macro which you may have seen in WWDC videos. Just as I told you, the macros interface and implementation are declared in separate files. Finally, please pay attention to this compiler plugin struct. This is where you register each macro implementation. If you forget to add it here, which I did more than once, the compiler won't resolve it. I find the location of the struct kinda confusing, so I prefer to make it more prominent by moving the struct to a separate file. As you can see, adding a macros package is pretty easy, and the built-in template does most of the tasks for you. Alright, next we can finally write our first macro. I'm back to my package file, and as you can see, I've moved some stuff around. Specifically, I renamed the implementation target and deleted the things I don't need. I also moved the macros plugin to a separate file, so it's easier to find. In the bird model, I want to add a new property for the user's favorite food. Its type will be an enumeration. For now, I'll declare it explicitly, just as you typically would. But in a second, you'll see why this won't be the final solution in this case. In the view, I want to display the other user's favorite food, but simply showing enum cases is not a good idea for many reasons. I'll need my enum to have a separate display name property. And as I'm adding it, you can see how much boilerplate this creates. What started as a 3-line declaration now has each option declared multiple times. So if I need to add, remove, or rename a case in the future, you can imagine how easy it is to make a mistake. Instead of doing all this, I'd like to just type a list of display names and have an enum generated for me behind the scenes. This is something I can easily do with macros. I'll start by writing my macros interface. Macros are introduced with the macro keyword, and those declarations are always public. That's because macros are defined in one module but implemented in another. There's just no way you can create a non-public macro. The macro signature looks similar to a function. It has a name and take a number of parameters. My macro will need to know the name of the enum and the options it should have. This macro's name starts with an uppercase D, while the stringify macro provided as an example starts with a lowercase s. You can name macros any way you want, but I find it clearer when declaration macros, which generate new types, are named just like types themselves, and expression macros, which perform actions or return values, are named like functions. Besides the signature, I need to provide a few details, such as the macro's role and the kinds of code it can produce. Using attributes, I'm telling the compiler this should be a freestanding macro which can emit new declarations. I'm also telling that declarations created by this macro can have any names. In most situations, I would prefer to restrict the name to some known pattern, because it makes the macro more predictable and easier to debug. The compiler will guarantee no other names can be used. But this macro gets the name from the user, so it can be anything, and arbitrary is the right choice for this. Don't be too surprised, but declaring a macro requires calling a macro. This external macro thing is used as a bridge between your macro's interface and implementation. You specify the target with the implementation and the name of the type which implements the macro. You do so using string literals, so it's important to not make any typos. Here I have a new file created in the implementation target. I start by importing a couple of frameworks and declaring an enumeration. You can just as well implement macros as classes or structures, but enumerations are enough for when you don't need an internal state. To make a type fill the shoes of a macro implementation, you need to declare a protocol conformance. There's a different protocol for each kind of macro. In my case, I'll use declaration macro. This protocol declares one static method, which expands the macro. I'll add something so the compiler error goes away. And I'll start implementing the macro by making sure it received the correct number of arguments. As you could see in the declaration, my macro takes two parameters, one for the enum name and one for its options. The important step is to register the implementation in the macros plugin. Right after that, I can already replace the enum I wrote manually with a macro call. Don't forget to import the macros interface as target. I'm getting a bunch of errors, but that was expected because of the fatal error call. These errors are pretty confusing because they don't fully explain the reason. Is it because the macro failed to compile, because it crashed while running, or something else? So it's a good idea to create an actual error type and throw proper errors from the macro. I'll declare a single error enum for all my macros, but in a real project I would probably have a separate set of errors for each macro. You can see the result of this change immediately. Instead of a generic message, my macro call now shows a concrete error name. Later in this video, I'll make errors even easier to understand by adding human-readable descriptions to them. And now's the time to actually implement the macro. First of all, I need to retrieve type name and options from the arguments. Unlike normal functions, the body of a macro is detached from its signature, so it cannot get the parameters directly. Instead, you use the node parameter, which has the arguments property. Working with arguments is not very convenient, because this collection uses a custom type for indices, so you can't use the normal subscripts. But my macro has only two arguments, and I can use first and last to quickly get them. Take a look at this guard expression. It may look complicated, but what happens here is pretty straightforward. I'll explain how I retrieve the options, and getting type name works pretty much the same way. Each element in arguments is a labeled expression syntax object. I don't need the labels, so I take just the expression. This expression holds the argument value, and since I know options is an array, I cast this expression to array expression syntax. If I'm wrong, this method will return nil and my guard will fail. I access elements and get a new kind of syntax. This array element list syntax exposes a couple familiar looking methods for transforming elements in a collection. I'm interested in compact map. Each element inside the closure is yet another syntax object. Once again, I only need its expression. I know that inside the array I should have strings, so I cast each element to the string literal expression syntax type. This type provides a quick way to access the entire string, no matter how it was constructed, via the represent literal value property. And finally, after quite a few transformations, options is just a normal array of strings. Once I have the type name as a single string and options as an array of strings, I'm ready to generate the enum declaration. You can do so in two ways, either by using syntax expressions or by just typing the actual source code as a string. The first way gives you more type safety and allows to compose expressions much like views in SwiftUI. But this time I'll use the second approach, because it's easier to read and most importantly supports more use cases. For example, I couldn't find a way to declare an enumeration with a computer property using syntax expressions. Maybe it's a limitation of the current Swift syntax version. Anyway, here's what I want to get in result. Of course, my macro doesn't know about the specific enum cases. Luckily, I can use string interpolation, which looks pretty much like always, except for this raw keyword. It comes from the Swift syntax package and tells the compiler to not perform any extra processing. I can interpolate type name as is, but for each option I need to do three things: lowercase its first letter, prepend the case keyword, and finally insert a new line at the end. Because options is just an array of strings, I use the familiar map and join methods. To match display names to each case, I use a similar approach. Firstly, I zip case names and options together, and then I put each pair of elements in this structure. I'm back to my actual macro code, and as you can see, it's exactly what I just described. I no longer need to throw the error, and at this point the macro is pretty much finished. Let's see it in action. I'll go to the model file and use the easiest way of debugging macros. I right-click the call and select Expand Macro. This command shows me the code generated behind the scenes. It looks correct to me, so I guess I can test the result in the actual app. The view updates and shows exactly what I wanted. So, from now on, if I need to define an enum which is then shown to the user, I can do it in just one line. That is the power of Swift macros, and it's just the beginning. Moving on to the next task, I see this fix me here. It's telling me I need a better way to check if the users are the same. Ideally, I would prefer just comparing the user objects directly. But of course, this is only possible if they conform to the Equatable protocol. Equality can mean different things. If I just add the conformance, Swift will infer the requirements. But it will do so in a way that checks each property, and sometimes you don't want that. In my app, for example, I only need to check the IDs. Once again, I can declare the conformance manually, but I suspect that in the future I'll need to handle similar cases, where Equatable depends on a single property. So for that, I'll create a macro which infers Equatable's requirements based on the marked member. It's gonna have just one argument, which is the name of the member. I'm using the string type here, even though it's less than ideal. I tried using a key path instead, but with the current Swift syntax version, that results in a recursion which crashes the macro. In the attributes, I'll tell Swift this is gonna be an attached macro which produces extensions. I'll also specify some additional details, like the name of the protocol and the name of the edit method. This time I know it beforehand. I'll create a file in the implementation target and once again implement the macro as an enum. From the node object, I need to extract the member name argument. Ideally, at this point I should make sure a member with this name actually exists and conforms to the Equatable protocol. I'll skip this because it's not really interesting. For the expanded code this macro emits, I'll use a mix of syntax expressions and string interpolation, so you can see how you can combine both. Extension declaration syntax lets me separately provide the declaration and the body of the extension. I insert the member name where it's needed, and at this point my macro should just work. Let's now remove the Equatable conformance I added manually, and instead ask the macro to infer the implementation based on the ID property. I'll add it to the compiler plugin here, and now I should see it working in my model. I use the expand macro command, and now I can see the generated extension. That means I can go to my view file and fix the code. Alright, it works. And if I change the operator, I can see the expected result too. So that is attached macros. More specifically, it's one of the supported kinds. Besides adding extensions and conforming to protocols, they can introduce new members such as computed variables, add attributes to the existing ones, provide additional accessors, and more. I showed you just one kind so you can get a taste of attached macros. Let me know in the comments if you'd like to see the others. Alright, looks like I have one last unfinished piece of work in my project. For now, I cannot implement the button actions. Let's say my backend's not ready yet. However, it's important that I don't forget about it later, and as you can imagine, to-dos aren't really prominent. So ideally, I'd like to have reminders pop up in the Issues Navigator. And for that, I'll create an expression macro. Just as I mentioned before, they can be used for two things: produce values or perform actions. You've likely seen macros that produce values in Apple videos, so this time I'll focus on the second kind. My macro will produce a compiler diagnostic which explains what needs to be done. I start declaring the macro as usual, and the attributes this time are very straightforward. My macro will ask the user for the comment which it will display. In the future, I may want to replace it with a ticket number, so looking up issues on GitHub or Jira becomes even quicker. In addition to the two familiar frameworks, I will also need to import Swift diagnostics, which come from the same Swift syntax package. Once I've got my stub created, I can register the macro in the compiler plugin and replace the to-dos with macro calls. They return errors at this point, but they will change soon. In the macro implementation, I need to extract the comment from the arguments. I bet this expression has already become familiar to you. To produce compiler messages, I need to create a struct which conforms to the diagnostic message protocol. It's surprising Apple doesn't provide a default implementation, given it needs so little input from my side. In the next step, I create a message and put it into a compiler diagnostic. Besides the message, this diagnostic needs to know where exactly the message should appear. In my case, it's just where the macro was called, so I simply pass the node parameter. Finally, I ask the context to produce the diagnostic. And because my macro doesn't change any code, I return an instance of void. I can see the result immediately in my view file. But I'm not done yet. What you've seen so far can be achieved with the built-in warning macro, but this tool won't suit me in the future. I already mentioned that I'm gonna change the plaintext comment to something else. And in addition to that, I'd like my macro to offer one-click solutions, something like that. They're called fixits. I'll have two of them, one for when I'm ready to implement the to-do right now, and another for when the change is no longer needed. In each case, I need to supply a message and the code change which should happen. Fixit message is another protocol you should implement yourself, but doing so is just as straightforward as the diagnostic message, so I won't stop here for long. And for the code change, I'm telling the compiler to replace the macro call with a placeholder expression. For my second fixit, the process is fairly similar, except this time I need to replace the macro call with nothing at all. Believe it or not, it took me a while to figure out how to do this, and the result looks surprisingly bulky. I add both fixits to the diagnostic, and once again, I can see the result right away. Just like that, one button allows me to implement the change, and the other to remove the to-do altogether. At this point, we've got all the three macros, and they seem to work just fine. We're not completely sure. You can, and should, cover the implementation with tests. That is what I'm gonna do just now. And in addition to that, I'll show you the debugging tools you can use to make sure your macro works as expected. In the previous sections, you've already seen this expand macro command. It may look too basic, but in my experience, it solved like 80% of all issues. But of course, it's not the only tool that's available to you. In fact, you can use all the normal tools, the debugger, breakpoints, and so on. However, they don't work when the macros run in the background, and every time in this video they ran like that. The debugging tools become available when you use a test or client target. I'll go ahead and recreate the test target I removed in the beginning. If you didn't remove it, then it's already there, waiting for you to write some tests. It's important to include this macros test support target as a dependency. I want to test my declaration macro, the one which generates enumerations for me. I've come up with a few tests for different inputs. Each of the test methods will use the assert macro expansion function, which comes from the test support target. This function makes sure the macro's output matches the expected value. The match should be exact, and I learned that the hard way. Turns out any indentation or white lines count too. What I'm doing right now is matching macro calls with their implementations. I need to do that explicitly, because the test target only depends on the macro implementations. It doesn't see the declarations. I've added a macro call and the code which my macro is expected to produce. Right now this test passes, but if I add an extra tab, it will fail. So yeah, not the most intuitive approach. Now let's look at what happens if one of my enums options has a white space. It may be something like this. I didn't handle this scenario in any way, so even the expand macro command is enough to see the error. In my tests, I'd like to make sure the situation doesn't cause any trouble. I'll check for white spaces in both the enum name and its options, but it's important that display names stay the same. As expected, the test fails. It does show the difference in output, but I wouldn't say it's very easy to understand. Maybe I just haven't gotten used to it. Let's go to the macro implementation and investigate this. I'll set a couple breakpoints and restart the test. Xcode pauses on the first breakpoint, and I can see that my case names contain white spaces when they shouldn't. I click through to the second breakpoint and see that display names look okay. So this means the problem should be somewhere here, where options are transformed into case names. My type name also has white spaces. I can fix both issues by just replacing all occurrences of a white space with an empty string. Let's restart the test and see if my change helps. Seems like it does, because case names have their white spaces removed while display names show them as intended. The type name also has the white spaces removed. So my second test passes, and it's time to write the last one. In this test, I want to see what happens if the macro doesn't receive any options at the call. In the end, it's technically possible to pass an empty array. However, displayable options without any options isn't really a thing. So instead of expanding, I'd like my macro to throw an error while not changing any code. As you can see, that's not what happens. The macro simply generates an empty enum. Fixing the macro code is easy. I just add another guard check. But now my test fails for a different reason. The message says the test didn't expect to receive any diagnostics, but it received one anyway. That's the error I threw from the macro. I'll update the test so this error doesn't come as a surprise to it. The test still fails, but this time it's because the error messages don't match each other. Of course, I could just update the test once again, but this unexpected arguments message isn't really informative. What I will do instead is declare a new error type specific to this macro. It's gonna have a single no options case, but it will also present this error in a human-readable way. With my background working with Cocoa, I normally use Foundation's localized error protocol to present errors. In macros, however, it doesn't work. What I need here is custom string convertible, and the description property will return the message my test expects. With all changes made, let's restart the test. It passes, which means my macro handles the no options scenario just as I intended. Okay, one last thing before the wrap up. Remember I told you have two ways to generate code inside macros. Because my demo examples were pretty short and simple, I mostly just typed the entire code as a single string. But now I'll show you the other approach. It's not gonna be very beneficial in this case, but in the previous section you saw that tests can be pretty picky when it comes to formatting and indentation, and this alternative approach allows you to think less about those things. So here I have my attached macro which generates equatable extensions. I'll replace this single block of code with function declaration syntax. This structure lets me separately type the function signature and body. Nothing changed in the resulting code, but I just don't have to think about all those indents anymore. Alright, that's it. By now you've seen how to write, use and debug macros. If you have any questions, suggestions or corrections, don't hesitate to leave them in the comments. I read everything. As for me, after getting some first-hand experience with macros, I would probably say using them is much more enjoyable than writing your own. That's mainly because the Swift syntax package is not very user-friendly. It makes you work with some low-level types for parsing and transforming the source code, and you don't normally deal with them on a daily basis. Also, some parts of the documentation are insufficient or simply missing. But one good thing about the package is that it includes some examples for various kinds of macros. I'll leave a link to them in the description. I will also give you a link to the collection of third-party macros, which you can just import and use right away. What a ride it was! But we're finally here. It's time to debug. I hope at this point you have a fairly good understanding of macros. Today I explained what they are, what they can and cannot do, how you create a macro, how you can use it in your app's code, and how to debug it if something's not working. As a bottom line, here's a few key takeaways from this video. Macros are basically standalone programs, completely isolated from your code. They can access and update only the syntax explicitly related to the macro call, not any code before or after it. Attached macros work in conjunction with another code structure and can extend it in a couple ways. For example, declare protocol conformances, introduce new members, and so on. Freestanding macros, on the other hand, don't depend on any existing syntax, but they can still generate code themselves. The new code can produce some value or compiler action, as with expression macros, or emit a declaration which didn't exist before, as is the case with declaration macros. Because macros are so isolated from the rest of your code, you declare them in a separate module. To be precise, you need two modules, one for the macro declaration and another for its implementation. You normally put both targets in the same macros package. Macros run after your code is parsed into an abstract syntax tree, but before it's compiled into machine code. At this point, they do their job, which is called macro expansion, and the results are compiled together with your original code. When you introduce macros into your code base, keep in mind their code will be checked just like any other, so invalid code in the macro will fail your entire build. And even though macros run in an isolated environment and have no access to the network or file system, you should still follow the secure coding best practices, especially when you integrate third-party macros. You'll find many useful links in the description. And in the comments, I invite you to share some ideas on how you can use macros to make your code safer and leaner. I've had a chance to use and write quite a few macros while working on this video, but I'm eager to get your perspective. That's it for today's video. It took quite some time to make, but in the process, I learned a lot about Swift macros, and not only them. If you learned something too, please give this video a thumbs up and subscribe to the Swiftbird. You can also support my future work at the links below. Stay tuned for more, and until then, make your macros fly.